This is Algebra Lesson 8-6, Geometric Sequences. A geometric sequence is a sequence in which the ratio between consecutive terms is constant. Ratio meaning fraction most of the time, or whole number that can be written as a fraction. Remember, when we did arithmetic sequences, there was a common difference, added or subtracted. This is a common ratio, something multiplied. A common ratio is the constant ratio between terms in a geometric sequence. Okay. So in Chapter 5, we looked at arithmetic sequences. In those sequences, there was a common difference. Today, we're looking at geometric sequences. In geometric sequences, there is a common ratio instead. To find the common ratio of a sequence, you're going to write each term over the term to its left and simplify. Start with writing the second term over the first term, and then the third term over the second term, and the fourth term over the third term, until you're out of terms. And repeat each term to make sure that the ratios simplify to the same. So let's take a look at this first problem here. We need to find the common ratio of 3, negative 15, 75, negative 375. We're going to simply do this. We're going to start with taking negative 15 and dividing it by 3. That becomes negative 5 over 1. Then we're going to take 75 and put it over negative 15. That becomes, if you reduce 75 over 15, that becomes negative 5 over 1. And then we'll take negative 375 and divide that by 75. That also becomes negative 5 over 1. So our common ratio here is negative 5 over 1. Or negative 5. You can leave it as a whole number. Most common ratios are fractions, but you can leave it as a whole number. Or its corresponding decimal. I prefer whole numbers or fractions. They're accurate. Number 2, if we're going to find our common ratio here, I would do 150 divided by 750. There's a fraction. If you reduce that fraction, you get 1/5. Then I would do 30 over 150. If you reduce that fraction, you get 1/5. Then I would do 6 over 30. If you reduce that fraction, you get 1/5. So my common ratio is obviously 1/5. For problem 3 here, find my common ratio, 6 divided by 4, which is 3/2. Then I can go 9 over 6, which is 3/2. Then I can go 13.5 over 9, which if you use your calculator should reduce to 3/2. So my common ratio here is 3/2. My last one. I have fractions. So it might be a little harder for you to remember how to divide fractions. So we'll refresh your memory here. This would be 3/2 divided by 3, which is the same thing as saying 3/2 times 1/3, which is 1/2. Remember, to divide is the same as multiplying by the reciprocal. So we take the next number, we're going to take 3/4 and divide it by 3/2, which is the same thing as saying 3/4 times 2/3, which is, again, 1/2. 6/12 reduces to 1/2. Last but not least, we will have 3/8. We're going to divide that by 3/4, which is 3/8 times 4/3, which is, again, 1/2. So my common ratio is 1/2. You should do all parts of the problem to make sure that you have a common ratio. Because sometimes you'll have a common ratio between the first 2 terms or the first 2 or 3 terms, but you won't have it all the way through, but then it's not a geometric sequence. So you must make sure, first of all, that you have a common ratio. The next thing we're going to do is we're going to be able to find the next terms in the sequence. In this case, 3 terms. In order to find the next 3 terms in the sequence, you have to find the common ratio first. Okay, so I'm going to look at 1, 3, 9, and 27. Some people go, oh, I already know you're multiplying 1 times 3, and 3 times 3 is 9, and 9 times 3 is 27. Let's double check and make sure that is our common ratio. 3 divided by 1 is 3, 9 divided by 3 is 3, and 27 divided by 9 is 3. So we'll multiply everything by 3, or 3 over 1. So 27 times 3 is 81. 81 times 3 is where if you get one wrong, you're going to be in trouble because you mess up the rest of them. 243. And 243 times 3 is 729. So there's the next three terms in our sequence, 81, 243, and 729. Let's go to our next problem. 120, negative 60, positive 30, negative 15. So we have to figure out our common ratio. Negative 60 over 120 is negative 1/2. 30, excuse me, it's negative 60 over 30. No, negative, I was wrong. Negative 60. Second over the first. 30 over negative 60. I lost my train of thought there for a second. 30 over negative 60 is negative 1/2. And then negative 15 over 30 is negative 1/2. So my common ratio is negative 1/2. So I'm going to have negative 15 times negative 1/2, okay, which is going to be positive 15 halves, or 7.5. Then I have positive 15 halves multiplied by negative 1/2, which is going to be negative 15 fourths. And then I'm going to have negative 15 fourths multiplied by negative 1/2, which is going to be positive 15 eighths. So my next three terms are 15 halves, negative 15 fourths, and positive 15 eighths. And if you want to change those two mixed numbers, be my guest. If they come out to be terminating decimals, you can do that as well. Number 3, 1.1 to 2.2, 2.2 to 4.4, 4.4 to 8.8. So common ratio of 2.2 over 1.1. Let's do 4.4 over 2.2. 8.8 over 4.4. My common ratio is 2. So I'm going to do 8.8 times 2. And 8.8 times 2 is 16.6. 16.6 times 2 is 33.2. And 33.2 times 2 is 66.4. So my next three terms are these numbers right there. So far, that's not too hard. Now, sometimes you have to be able to determine whether or not we have a geometric sequence or an arithmetic sequence. And you can look for a common difference or a common ratio to determine whether a number sequence is geometric or arithmetic. If there is no common difference and no common ratio, then it's neither arithmetic nor geometric. It may be a different type of sequence altogether, or it may not even be a sequence at all. So let's take a look at something. Let's determine whether or not these are arithmetic or geometric sequences. 2 to 4, 4 to 6, 6 to 8. Okay? If we look at this, we're going up by 2 each time. We're adding 2, adding 2, adding 2. If you're going to add something that's a common difference, and a common difference is an arithmetic sequence. This is an arithmetic sequence. 2 to 4, 4 to 8, 8 to 16. Well, this looks like we're multiplying by 2, and if we multiply by something, that means there's a common ratio, because if I take 4 over 2, that's 2. 8 over 4, that's 2. That's a common ratio, so this is a geometric sequence. 162 to 54, 54 to 18, 18 to 6. Okay, let's take a look at that. Going down significantly fast, so I'm not thinking it's going to have a common ratio, so I'm going to look at the division part of it. Okay, take the second number divided by the first number. Okay, so 54 over 162 is 1/3. And then we're going to do 18 over 54. Also 1/3. And 6 over 18 is definitely 1/3. So it's a geometric sequence. If you're multiplying or dividing something, it's going to be geometric. If you're adding or subtracting something, it's going to be arithmetic. However, you have to multiply or divide the same thing for it to be a geometric sequence. It has to be the same ratio every time. And for an arithmetic sequence, you have to be adding or subtracting the same thing in in order for it to be an arithmetic sequence. Let's look at this last one. 98, 101, 104, 107. Okay, 98 to 101, I'm going to add 3. 101 to 104, I'm going to add 3. 104 to 107, I'm going to add 3. 3, so it has to be arithmetic. Now, if you remember, we have this special formula for arithmetic sequences. We're going to look at and see if there's a special formula for geometric sequences. You can use a common ratio of a geometric sequence to write a function rule for the sequence. Let's look at the sequence 2, 6, 18, and 54. Okay, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, so its common ratio is 3. So if we let n equal the term number in the sequence, a of n is going to be the value of the nth term. Okay, so my first term is 2. There's my first term right there. My second term is 6, which is 2 times 3 to the first. Remember, my sequence was, I'll rewrite it down here so you can see it, 2, 6, 18, and 54. Okay, my third term, 18, is 2 times 3 times 3, or 2 times 3 to the second. 9 times 2 is 18. 18 times 3 became 54. Okay, so that becomes 2 times 3 times 3 times 3, or 2 times 3 to the third. Notice, each time you go up, the exponent is 1 less than your term number. Your exponent is always 1 less than your term number. So we can kind of write a rule for this. In general, you can write a function rule using the first term, the term number, and the common ratio, just like we wrote function rules for arithmetic sequences with the first term, the common difference, and the term number. Okay, we can do the same thing with geometric sequences. It follows that geometric sequences of a of n equals a times r to the n minus 1, where n is the nth term, a is the first term, r is the common ratio, and n is the term number. Okay? So let's take a look at something. Let's find the first 6 and the 12 terms of each one of these sequences. Okay, so I'm going to find a of 1. That's going to be 4 times 3 to the 1 minus 1. Remember, you don't put anything in here except for the first term, the 6th term, or the 12th term. It's not a formula we're solving. It's just you're plugging in. So a of 1, or so in other words, my first term, is 4 times 3 to the 0 power. 3 to the 0 power is 1. So 4 times 1 is 4. Okay, which makes sense because what is the first term? It's 4 right there. We should have known that from the formula itself. So that proves it, verifies it. I need my 6th term, so a of 6 will equal 4 times 3 to the 6 minus 1. 4 times 3 to the 5th power. So remember, you have to do order of operations. 3 to the 5th power has to come first. So 3 to the 5th power is 243, so I'm going to do 4 times 243. And that ends up to be 792. So 792 is my 6th term. Now I need my 12th term. A of 12 is going to equal 4 times 3 to the 12 minus 1, or 4 times 3 to the 11. 3 to the 11th power is 177,147. Multiply that by 4. I'm going to get 708,588. Very big numbers. So there's my 12th term, there's my 6th term, there's my first term. Very similar to arithmetic sequences, just instead of having a common ratio, a common difference, you have a common ratio. Okay, very, very similar, and you apply the same rules. So let's take a look at the next problem here. A of n equals negative 2 times 5 to the n minus 1. Okay, so we're going to do this rule. So I need my first term. My a of 1, I've already figured this out, should be negative 2. Because it should be right there. That's my first term. Let's check and make sure it actually works. So we're going to do negative 2 times 5 to the 0 power. 5 to the 0 power is 1, and 1 times negative 2 is negative 2. It did work. A of 6 means we're going to do negative 2 times 5 to the 6 minus 1, or 5 to the 5th power. So 5 to the 5th power is 3,125, so we got negative 2 times 3,125. And that will would be negative 6,250. So there's a of 6, this is a of 1. Now we need a of 12. Negative 2 times 5 to the 11th power, so we're going to have 12 minus 1. 5 to the 11th power is going to be a very large number. Multiply that by negative 2, and you're going to get negative 97,656,250. Not a very big number. So those are your three terms. Your first term, your sixth term, and your 12th. Very similar to arithmetic sequences, applied slightly differently, and you have geometric sequences.